Question 8b is basically asking the same question that 8a did, but in this case we are asking about calories instead of joules. So the specific heat of water, 1 calorie per gram degrees C, is simply a different unit of energy. Okay, in the previous version we had joules per gram degrees C. Here we have calories per gram degrees C. But it's still S, so we're going to approach the problem the same way. Q equals ms delta T. Our mass is still 25 grams times 1 calorie per gram degrees C times 8 degrees C. Okay, so our grams will cancel, our degrees C will cancel, giving us an answer in calories. So 200 calories. Okay, or if I'm being careful about sig figs, I would say 2 times 10 to the 2 calories. Okay, because remember, we only have 1 sig fig here. Right, one of the things that you're going to need to do, this is a very important skill, is to be able to rearrange this equation to solve for different things, because sometimes you might have to solve for mass, sometimes you might have to solve for S, sometimes you might have to solve for delta T. And you need to be able to rearrange the equation however you want. Okay, so if I'm going to take this equation and I want to get T by itself. Okay, in order to do that, I'm going to take and divide both sides by ms. Okay, so on the right-hand side of my equation, my m's will cancel and my s's will cancel. So what we get is Q equals ms, or excuse me, Q divided by ms equals delta T. All right, so that's our first choice right up here. All right, so question 10. So when 349.2 joules of heat energy are added to a 150 gram block of metal, the temperature increases by 6 degrees. What is the specific heat of this metal? Now I want you to think about some of the things that are in this problem. Okay, so the temperature increases. Okay, so what happens when we warm something up? Okay, think about maybe like a pot of water on the stove. In order to warm up that pot of water, I need to add some heat to it, right? I need to pump in some heat energy. Okay, so heat is going in, so that means that 349.2 should be a positive value, right? We're adding heat in. It even says so, added, okay? So in our temperature increase is 6 degrees. That is our delta T. Right? And we're given grams, and we're given Q, which is our heat energy. Right? So Q equals ms delta T, and we have Q, we have mass, and we have delta T. So let's rearrange to get S by itself. So I'm going to divide both sides by m delta T. Right, so my m's will cancel out and my delta t's will cancel out. So Q over m delta T equals S. Right, so my Q was 349.2 joules divided by my mass, which was 150 grams, times my delta T, which was 6 degrees. Okay, none of my units will cancel out here, right? So what I should get is 0.388 joules per gram degrees C. And really it should be if I'm careful about sig figs. Even Dr. Lyon has to remember sometimes. Okay, moving on to question 11. Let's look at this one. So if 553 joules of heat energy are added, okay, there that is again, we're adding heat energy, so that 553 joules should be positive Q, are added to 315.5 grams of water, how much will the temperature change? Okay, and in this problem, we're assuming that you already know by now that S for water is 4.184 joules per gram degrees C. Okay, so we've got Q, we've got our mass, and we have our S. Oops. Okay, and in this question, we're asked how much will the temperature change? So what is delta T? So let's get delta T by itself by dividing both sides by ms. So delta T equals Q over ms. So our change in temperature will be 553 joules. That's our Q. Our mass was 315.5 grams. And our S is 4.184 joules per gram degrees C. All right, so my grams will cancel. My joules will cancel, leaving me with an answer in degrees C. We'll find that it comes out to be 0.419 degrees Celsius. Good old water. That's a whole lot of heat energy to pump into that water, and it only changed by ½ degree Celsius. Thank you very much. All right, now let's think about some other aspects of this problem. So we've added some heat energy to our water. So the water should warm up. Okay, so if delta T is positive, that means that our temperature increased. Okay, which is what it should do, right? If we're adding heat to water, it should warm up. Okay, so a lot of these questions, if you stop and think about them, they will make sense if you've done the problem correctly. Right, if we did this problem when we came out with a negative 4,000 degrees Celsius, something went wrong. Okay. All right, so a 100-gram gold nugget initially at 19 degrees Celsius absorbs 250 joules of heat energy. What is the final temperature of the gold? Right, now let's, like I was just saying in the previous problem, let's analyze some of the information that we have. Right, a gold nugget at 19 degrees Celsius absorbs some heat energy. So if we're pumping heat into that gold nugget, the final temperature should come out higher, right? We're warming the nugget up, right? So we have Q equals ms delta T. And remember, delta T itself is temperature final minus temperature initial. Okay, so we're going to solve for delta T first, and then we'll figure out what the final temperature is. Right? So from previous problems, we know how to rearrange, so I won't go through that every single time. Right? But suffice to say that we take our original equation, divide both sides by ms. Right? So we have 250 joules, that's our Q, and our mass was 100 grams. And we're given the S of gold, which is 0.129 joules per gram degrees C. Okay, so we'll find out that our change in temperature, our delta T, is 19.4 degrees Celsius. Okay, that's our delta, that's our change. That's not the final temperature. That's the change in temperature. Okay, so if delta T equals T final minus T initial, then T final equals delta T plus T initial. Right, so in this case, our delta T was 19.4. Our initial temperature was 19. So T final is 38.4 degrees Celsius. Okay, so our initial temperature was 19. Our final temperature is 38.4. So our gold nugget warmed up, which is what we figured it should do if we're adding heat energy to our gold nugget. Okay, our next piece. So a piece of lead absorbs 100 joules of energy, and its temperature increases 15 degrees Celsius. What is the mass of this piece of lead? And we're given the S of the lead. Q equals ms delta T. So our 100 joules, that's our Q. Our temperature increase, that's our delta T. And we're given the S in the problem. So we're going to rearrange the equation to solve for mass. So I'm going to divide both sides by S delta T. So my S and delta T's will cancel. So mass equals Q over S delta T. So our Q was 100 joules. S is given to us as 0.130 joules per gram degrees C. And our delta T is 15 degrees C. Right, so C's will cancel, joules will cancel, leaving us with grams left over. And we find out that it is 51 grams of lead. And we're going to go ahead and cut things off right here, and we'll pick it up on our next video talking about a thing called a calorimeter.